Hello everybody. Today I'm going to explain what are sound harmonics. Alright, let's get started. Alright, so what are harmonics? Harmonics are based on the mathematical harmonic series. They have a wide variety of applications, but harmonics of a sound wave or a sinusoidal wave is a wave with a frequency that is a positive integral multiple of the original frequency. Now in this case, a black wave is the original wave, and the frequency of that wave is called fundamental frequency or first harmonic. Now the red wave is the second harmonic because it is twice the frequency. The frequency of the red wave is twice that of the fundamental frequency, and hence is termed as the second harmonic frequency. Now all harmonics are periodic at the fundamental frequency, and the sum of the harmonics are also periodic at the fundamental frequency. Now let's look at that with an example. Alright, in this example, let's say 50 Hertz frequency is the fundamental frequency and the positive integral multiples are 100, 150, 200 and so on. So right from 100, 150, 200 they are the harmonics, and my first statement was all harmonics are periodic at the fundamental frequency. So all these harmonics, since they are integral multiple of the fundamental frequency, they are periodic. And the second statement, the sum of harmonics, they're also periodic at the fundamental. Meaning, let's say, consider 100 Hertz and 150 Hertz. The sum is 250, which is nothing but 5 times the fundamental frequency, and hence is the fifth harmonic, periodic at the fundamental. Alright, this is the equation of harmonic frequencies. So f prime is n times f. F is a fundamental frequency, f prime is harmonic frequencies, and n is a positive integer starting from 2 all the way up to infinity. As we discussed the equation earlier, f prime is n times f, and n is always a positive integer. Now, if n turns out to be even, then the harmonics are called even harmonics, and if n turns out to be odd, they're called odd harmonics. Now, I'll be playing the sound files for even and odd harmonics. Alright, this is a 100 Hertz and its harmonics waveform. So 100 Hertz is the fundamental frequency, followed by harmonics, all harmonics indeed, such as 200, 300, all the way up to 1000, and this is how it sounds like. Alright, here's a spectrograph of 100 Hertz and its harmonics. So the fundamental frequency here is 100 Hertz, followed by the harmonics, which are all harmonics 200, 300, 400, all the way up to 1000 Hertz. Alright, this is a waveform of 200 Hertz and its even harmonics. So the fundamental frequency here is 200 Hertz, followed by even harmonics such as 400, 600, 800, 1000, and 1200 Hertz respectively. And this is how it sounds like. This is a spectrograph of 200 Hertz and its even harmonics. So the fundamental frequency is 200, followed by 400, 600, 800, 1000, and 1200. This is a 300 Hertz odd harmonic waveform, so the fundamental frequency is 300 Hertz, followed by the odd harmonics such as 600, 900, 1200, 1500, and 1800 respectively, and this is how it sounds like. After listening to 200 Hertz even harmonics and 300 Hertz odd harmonics, you would have noticed an audible difference where odd harmonics sounds much rougher and even harmonics sounds much softer. That's because the even harmonics are made up of octaves and fifths, whereas odd harmonics are made up of thirds and form a dominant seventh chord. This is a spectrograph of 300 Hertz and its odd harmonics. So the fundamental frequency is 300 Hertz, followed by odd harmonics 600 all the way up to 1800. Alright, so harmonics may be referred to as overtones sometimes, but they're literally not the same thing. So in this example, the black wave is a fundamental frequency or the first harmonic. The red wave is a frequency twice that of the fundamental and is referred to as a second harmonic frequency. Now, if there is a third wave which has a frequency thrice that of the fundamental, obviously it's going to be called the third harmonic. Now, how does overtone come into this picture? So the second harmonic frequency is nothing but the first overtone. And if there's a third harmonic frequency, that's going to be the second overtone. So harmonics are nothing but the amalgamation of all the frequencies, including the fundamental, whereas overtones are the amalgamation of frequencies above the fundamental. Now, sound harmonics are the real reason why the A note in the piano doesn't sound the same as an A note in the guitar or the A note in any other instrument. They are really important in defining the timbre or the sound quality of an instrument. Many a times, overtones or harmonics are added to the original signal to enhance the characteristic of the sound, to make the sound more lively, more natural. Alright, thank you for watching this video. I hope you enjoyed it. Have a great day.